My name is Samir, and I help to guide the development of MapleFlow. That's a new calculation tool developed and released by MapleSoft. There's a wealth of math software on the market, and they all have their own unique and compelling design features. This webinar will explore why you might want to use MapleFlow instead of the other tools. Those other tools also include Maple, another tool from MapleSoft for any application with a strong mathematical focus. First of all, what I'd like to do is describe what MapleFlow is like to use. The most natural working environment of all is a piece of paper. Anyone can grab paper, a pen, and start jotting down notes and calculations straight away. I work in a tech-heavy industry, software development, and people still take notes on paper in preference to a tablet and a stylus or a computer. And I think everyone recognizes there's a very good reason for that. There's a certain tactile feedback, a certain immediacy that you get from paper that you don't get anywhere else. With MapleFlow, we've attempted to reproduce the design metaphor of paper on a computer, but with a math engine under the hood. This enables MapleFlow to support a very natural workflow, one that places a human at the center of the problem-solving process, not the computer. Most scientists and engineers, when they start a design calculation, don't have all of the steps planned out in computational detail. They don't have a grand plan. They have a vague sense of where they want to end up, and perhaps an even vaguer sense of how they want to start. They try things out, they correct, they go back, they progress a little. They make baby steps, and they gradually mold their initial thoughts and ideas into a full technical analysis. MapleFlow encourages and even supports that workflow. And if you're the right kind of person, MapleFlow is actually rewarding to use. It's enjoyable. It has what I like to call simple game mechanics, but within the framework of those simple game mechanics, you have unlimited creativity. So these are some of the supporting features in MapleFlow. You can place math text, images, and plots anywhere on a canvas. The canvas is what we call the MapleFlow environment. Any math evaluates from left to right, top to bottom. All math is always up to date. If you change a parameter, that change cascades down the length of your MapleFlow canvas, and all the dependencies, plots, results update to reflect the new parameter values. We've programmed in fluid navigation with the mouse and the keyboard. If you don't like to take your fingers off the keyboard, you don't have to do that. You can create math, text, plots, you can move things around, all with keyboard shortcuts. Your equations are readable, they're in natural math notation, there's built-in support for units, and perhaps most significantly, there's a very broad, very deep mathematical library powered by the Maple programming language. As I said at the beginning of this webinar, there are other math tools on the market, and on the next slide, I'll compare them. There are tools that share some of the same design features as MapleFlow, but Flow is the only tool with all of these features. You have documentation and math in the free-form Scratchpad interface with a very strong mathematical engine powered by the Maple programming language. You have mathematical functions covering the whole breadth of science and engineering. The interface is designed as a daily driver for the calculations that you do every day, something that's easy to dip into and out of whenever you need to. There's support for units and flexible licensing as well. If all of those tick the right boxes, then MapleFlow probably deserves some consideration from you. So let's go on to a somewhat more moderately detailed comparison. Math software tools are are very complex. They all have thousands, perhaps tens of thousands of functions and user interface features. Comparing the different tools is very difficult, if nigh on impossible. And to complicate matters, users don't have all of the same requirements. Some are interested in a small subset of the functionality and don't care about anything else. Some are also interested in the support provided by the vendor. They consider that a product feature. Can they email the developer and get a prompt response? And they might even consider flexible licensing a feature as well. Producing a comparison that covers every single use case or function is generally very difficult. You have to handpick the dimensions along which you compare the tools. If you pick too few, the comparison is simplistic. If you pick too many, then the comparison is impossible to digest. I've chosen 5 that will be important if Mapleflow fits your use case, fits your workflow, if it's the right tool for you. Math, units, technical reporting and documentation, the flexibility of the licensing, the ease of use or how high or low the barrier to entry is, and the type of calculation you might be doing. If you were going to compare why you might use another tool, say Matlab, instead of any of the other tools, you would use a different set of dimensions. Those would include programming and the speed of computation. Let's go through each of these in turn. I've scored each tool on a scale of 1 to 4 as objectively as I can. Let's start off with math. Some tools let you do a lot of math, some only very little. Of course, the term math is very broadly and frankly ill-defined. Math might be simple calculations, differentiation, solving equations, or image processing. A typical math tool might have thousands of functions, and some choose to concentrate in one area, others in another. So this dimension of the comparison has to be interpreted against what's important to you. Having said all of that, generally speaking, Mapleflow, Maple, Matlab, and Python all do lots of math. They all have many different math functions and routines covering the whole spectrum of science and engineering. Secondly, units. If you're a scientist or an engineer, then nearly every quantity and parameter you use has a unit. It has a dimension, and the units matter. You have to get them right. All the tools listed here, apart from Excel, let you use units in some way or another, but the usability and the implementation differs. With Matlab, for example, units are not available in the base package, but through the optional symbolic math toolbox. Units are available through Python packages, but they're not really interested into the entire Python ecosystem. So technical reporting and documentation is potentially more important than the math for many people. You might want to archive and document your analyses. You might want to share reports with a colleague or a client, and more. Mapleflow and Mathcad are all quite unique in that they equally stress documentation. As I've mentioned previously, the flexibility of the licensing is important. It could be a key determining factor. You might want perpetual or subscription licenses. Home use or second install options might be critical. You might also be interested in the ease with which you can move licenses from one computer to another. Vendors may not offer all of those options or provide the software and a licensing package that you want. In that respect, Mapleflow and MapleSoft are generally very flexible with licensing. Let's talk about ease of use, or how shallow the learning curve is. Some tools are very fully featured, and they have a complex, rich syntax for doing complicated things. But that power means that they take some time to learn. Other tools are simpler. That restricted focus means that you don't take as long to become proficient in the tool. So along this dimension, I've actually given Microsoft Excel full marks, mostly because Excel is basically a native language for nearly every technical person. I doubt there are many people who haven't touched Excel early on in their computing experience. Mapleflow and Mathcad both rate very highly in this regard. So let's talk about the final dimension of the comparison. What is the tool meant to do? Well, in all of these tools, 1 + 1 is equal to 2, but the actual design and philosophy of each tool lends itself a different application focus. What is the intended use for the tool? Is it high-speed number crunching, mathematical research? Is it mathematically oriented algorithm development, or something else entirely? Do you want to do complex math, or are you happy with a lower technical ceiling? Well, frankly speaking, the vast majority of people don't really push the boundaries of mathematical computing. Their mathematical needs are rather more prosaic. They're rather simple. They're doing simple to mid-range calculations, and I'll talk about what that means in the next slide. They'd probably self-identify as scientists or engineers, and all they need is a daily driver for their regular calculations with a need to make notes and document their work. And that's the market that Mapleflow is very firmly aimed at. So what do I mean by simple to mid-range calculations? Well, you might use the term design calculations instead. And here are some examples of design calculations across several disciplines. These are all calculations amenable to be implemented in Mapleflow. Of course, this is in no way, shape, or form an exhaustive list, but it gives you some sense of what are Mapleflow's target applications. Basically, if your work is focused on the application of math to solve technical problems, then Flow is the right tool for you. For example, if someone wants to analyze the frequency content of a signal, by and large, they're not really interested in implementing their own discrete Fourier transform function. They just want one that works out of the box quickly and efficiently. If a civil engineer wants to design a concrete retaining wall, well, the equations and methodology are already defined and established in design guides that they can't deviate from. They just want a tool to implement and document those equations and why those equations were chosen. If someone wants to iteratively solve a set of pump design equations, they just want a numerical solver that works. They're not going to code up their own solver just to do that. So I mentioned previously that Maplesoft have another math tool called Maple. I want to draw a distinct line between Maple and Mapleflow. Maple is designed to support advanced, mathematically oriented work for science and engineering. You might be deriving equations, developing an algorithm, or creating a user interface. The nature of that work means that Maple is the right tool for you. Its environment is amenable to the work that you want to do. Mapleflow, on the other hand, is the daily driver that you might want to open up to create a quick design report, or if you have a technical analysis that you just want to implement quickly and refine later. Maple can do more math than Mapleflow, but that increased power means that you need to put a little bit more time in learning how to use this. Mapleflow, however, has a much more tightly defined focus and a lower technical ceiling. That means the tool can be slimmed down and made easier to digest. So what I'd like to do now is actually quickly dip into Mapleflow and show you what it looks like. So this is the home screen of MapleFlow. There are 3 buttons: one to create a new canvas, another to access a built-in series of tutorials, and one more, an application gallery. Let me click on this. This is an end product gallery of pre-engineered applications across a number of disciplines. I'm just going to select one of them. Let's say this one. So this is what a MapleFlow application looks like. At the top, we have a title, a diagram, and a description of the problem. If I scroll down, you can see that we have some parameter definitions, some equations. I solve those equations, and I see my results. Everything you see here is in a container. So I can move these containers about on screen. So I can move this about on screen. If I click here, I can add new math very quickly and efficiently. Moreover, I have sections in this report. If I double click on this section line, that collapses. I can double click on that to expand it. If I change a parameter value, that change cascades down the length of my MapleFlow canvas, and all of the results dependencies update to reflect the new parameter value. If I do that again, you might see some numbers change here, and this plot updates as well. There may be situations in which I don't want to see the commands, only the results. So what I can do with this plot is actually right-click on this and select Hide Commands. That command is still there, but it's not visible, it's under the hood. Let's start a new canvas, and I'll show you a few things from scratch. So I can click anywhere to place this grid cursor at my desired point, or I can move it about with the arrow keys on my keyboard. I can start doing math straight away, creating definitions and using those definitions in my analyses. I can move things about with my mouse just by clicking and dragging, or I can move things about with my keyboard as well. I can also create text, and in a similar style to Microsoft Word, I can also apply different styles to this text. If I change a parameter value, that change cascades down the length of my MapleFlow canvas, and all of the results and dependencies update to reflect the new parameter value. Since MapleFlow evaluates from left to right, top to bottom, if I grab this and move it to this point, well, this equation doesn't know what the value of x is anymore, so it's left as an undefined name. Move it back up. There we go. There are also many functions you can use in MapleFlow. So for example, one function I use on a regular basis is this function for solving an equation or a group of equations. There's about 6,000 or 7,000 functions in MapleFlow covering virtually every area of math. There are many interesting nooks and crannies you can explore. So for example, if you wanted to, you could ask MapleFlow to give you the enthalpy of water at a temperature of, let's say, 300 Kelvin and a pressure of 1 atmosphere. There we go. There are many other tools and features in MapleFlow that I can show you, but I'm going to put that to one side. If you want to know more about the operation of MapleFlow, then there are videos you can watch on our YouTube channel, and there's much more information on our website as well. So there's our website address. You can download a free trial of MapleFlow, and we're more than happy to give you a demo, a personalized demo of MapleFlow as well.